Hi everyone, welcome to another video of Calculus 1. In this video, I am going to explain some rules that we can use in finding the derivatives of functions. Particularly, I'm going to talk about the product rule and chain rule, and then by using those two, I'm going to take quotient rule. And then also going to work out some problems. Okay, let's look at the product rule. Product rule. If I have two functions, if I have f and g are differentiable functions, then fg is also differentiable and fg prime of x is equal to f times f prime x gx plus fx g of x. Uh, for example, if you have y equals f of x and u equals g of x, uh, you can find yu dx, right, is equal to in this way. So for example, let's take an example. Let's take an example. That way it's easier. You take example, find the derivative of h of x. Example, you get a derivative of h of x equal x squared 9x plus 2. So here is f of x is x squared, g of x is 9x plus 2, right? Now we identify what those functions are first. And then h of x is now what is f of x times g of x, right? All are differentiable functions. And then we can find h prime x, which is equal to d over dx f g, right? So you can write f g times df over dx plus g times, sorry, f times g dg over dx. So g is in this case 9x plus 2 d over dx x squared plus f is x squared. This is d over dx. G is 9x plus 2. So this is 9x plus 2, 2 times x, right? uh, plus x squared, uh, you can use the sum rule here, d over dx 9x plus d over dx2, right? And then we use 9x plus 2, 2x plus x squared. This is 9 times d over d over dx x, so that's equal to 1, 1, right? 9 times 1 plus this is 0. So we have here 18x squared plus 4x plus this is 9x squared. So we have altogether 27x squared plus 4x. 27x squared plus 4x. That's h prime x. Okay. So that's how you do use the product rule. Let's take another example. We have d over dt t squared e to the power t. So two functions are t squared and e to the power t. So take the first function and take its derivative, and the second function you just multiply with that derivative. So e to the power t times d over dt t squared plus, now just write the t squared here and find the derivative d over dt e to the power t here. So we have e to the power t times 2t plus t squared e to the power t. You can take e to the power t out, and t also out, one of the t, it's a common factor. So basically you can take t times e to the power t, then here it's 2 plus t. So that's your derivative of that function. Okay, let's learn the chain rule. Now you can do many problems like that by using the product rule, and I'm going to use uh, some of those later. But let's look at the chain rule. Now, chain rule is useful when you have a composite function. Let's take like this. What is a composite function? If you don't remember what composite function is, uh, just go ahead and look at the composite function video that I post uh, that is posted earlier. So a composite function is denoted by f naught. Let me take another color. F naught gx, which is f of g of x. Now let's take an example. It is very easy to follow this up with the example. Y equals square root of x to the power 4 plus 1. Now I take u equals g to the g of x, which is equal x to the power 4 plus 1. Now I can write y equals uh, square root of u, so which is actually function of u, fu. Now I can write y again, f of u is g of x, right? Which is actually f naught g x. So what does this do? F maps uh, G maps actually through x to u, and then f map u to uh, another function called f of g of x. So that's called a composite function, right? That's composite function. Now I want to find dy over dx. This is what I want to find. We're going to use chain rule. For this, we're going to use chain rule. Chain rule tells us dy over dx is equal to dy over du, because y is a function of u, times du over dx, because u is a function of x. So that's it. This is what we call the chain rule, right? So here y equals fu and u equals g of x are differentiable functions. Okay, so if I use that in my previous question, right, I can find du over dx equals d of du, what? What is y? Y is square root of u times d over dx. U is x to the power 4 plus 1, right? So this is du over dx, the du over u to the power half plus d over dx. I can use the sum rule here, d over dx x to the power 4 plus d over dx 1. So this is n equals half, so it's half n x to the power minus 1 is u, yeah, instead of x you have u half minus 1, right? This is x to the power 4, that means 4x 4 minus 1 plus this is 0, this is a constant, right? This is 4 minus 1. So we have half u to the power negative half. This is 4 times x cube plus 0. So this is 2 cube. We have 2x cube, 2 times, hold on, I just want to skip that step of 2, and then you have half u to the power negative half. U is what? U is equal to x to the power 4 plus 1. So I'm going to replace this one, uh, x to the power 4 plus 1 negative half times 2x cubed. Now I can cancel this to that, and then you get x cubed times x to the power, or this been 4, right? This been 4. So this is 4, 2. So 2x cubed x to the power 4 plus 1 to the power negative half. Or you can write 2x divided by square root of x to the power 4 plus 1. Right? That's the answer by using the chain rule. Now it's just a matter of identifying what the composite function is in here. Let's do another example using the chain rule. Okay, and what you're using here is the chain rule and your uh, chain rule and basically the uh, summation rule and also uh, constant multiple rule, right? So you have y equals x squared plus 7x plus 2 to the power negative one third. Now I define my u. U is equal to the inner function x squared plus 7x plus 2. That's my u, which is actually g of x. And then I defined y, which is it's going to be u to the power negative one third, which is f of u. Now I want to find du over dy, sorry, dy over dx, which is equal to y over du times du over dx, right? That's from the chain rule, okay? And what is y? D over du, u to the power negative one third times du over dx, d over dx, uh, x squared plus 7x plus 2. So this is just like x to the power n. So you have negative one third times u, negative one third minus 1. And then you can use a sum rule, d over dx, x squared plus d over dx 7x plus d over dx 2. So this is negative one third, and this is u to the power negative 4 thirds, times this is d over dx squared. So this is 2 times x 2 minus 1 plus constant 7 out. Then you have d over dx x plus this is 0. And here you have negative one third, u to the power negative 4 thirds, and then you have 2x plus 7. This is 1, 2x plus 7. And I can substitute for u. U is x squared plus 7x plus 2. So I can put negative one third. Here it's x squared plus 7x plus 2 to the power negative 4 thirds times 2x plus 7. Uh, I can further simplify this by moving this into the denominator, the negative power. So if I do that, it's going to be negative 2x plus 7 divided by 3 times x squared plus 7x plus 2 4 third. That's dy over dx. And if you take another function, y equals e to the power uh, x plus 2 uh, let's say uh, e to the power x squared plus x squared times x plus 2, for example. Okay, now I can use our knowledge of chain rule as well as the um, product rule, and then also use the the other rules. So I define this one as u as x squared times x plus 2, which is g of x, right? And then I'm going to use y equals e to the power u, which is actually f of u. Now I want to find du, sorry, dy over dx, which is dy over du times du over dx. Now here in this case, y is equal to d e to the power u du e to the power u plus d over dx x squared times x plus 2, right? So these have a product. So I have e to the power u is just e to the power u times, using the product rule, we have x squared d over dx x plus 2 times plus x plus 2 times d over dx x squared. Now this is e to the power u, and here in this case we have x squared uh, d over dx x plus d over dx 2 plus x to the power x plus 2. This is 2 times x 2 minus 1. Okay, so you have e to the power u. This is x squared. This is d over dx x is equal to 1 plus 0 plus x plus 2 times 2 times x. So you have e to the power u here x squared plus this is 2x squared plus 4x, 2x squared plus 4x, right? And you can take this is 3x squared plus 4x, and this e to the power u 3x squared plus 4x. You can take x and substitute for u. You can put x e to the power x squared times x plus 2, and you have 3x plus 4. Well, that's the solution. Okay, we used here identifying functions, and then use the chain rule, and then use here the this is chain rule, and then use the product rule, and then here use the sum rule, right? And then we use here in this case we use that d over dx x to the power n, n minus x to the power minus n times x to the power minus n. So those are the rules that we used so far in this case. So we learned product rule and chain rule. So the last one is a combination of product rule and chain rule, which is the quotient rule. Well, sometimes the quotient rule is given as a standalone functions, but I don't like to do so. So what I would do is I would introduce that as a uh, extension of chain rule and then the product rule. So what I can do is I can take if uh, you have if you want to do something like this, uh, d over dx uh, f over g, right? F over gx, fx over gx, so f of x over g of x. Uh, I can write this is very much d over dx f of x times g minus 1. Okay, I can write uh, g of x to the power negative 1. Okay, and then I can use u. So I just wanted to find now I can put the product rule for this one. I can put the product rule for this one. I can put uh, g of x negative 1 to the power negative 1 and d over dx fx, okay, f of x plus f of x times d over dx uh, g x to the power negative 1. Okay, then I can say that my u is g of x. Okay, u is g of x, and my y, sorry, first I would introduce y. I name y is g of x to the power negative 1, and I define u is g of x, right? And then y equals u to the power negative 1, which is hu, right? U to the power negative 1 is hu. So I want to find this is d over dx g x to the power negative 1 is equal to dx d over dx d over dx negative 1, that is equal to d over dx uh, hu, right? So I have to use the chain rule here. So that's going to be d over d uh, u uh, hu times uh, hu times du over dx. Okay, du over dx. So this is uh, d over du u to the power negative 1 times du is gx over dx, right? And this is negative 1 u to the power negative 1 minus 1, and this is dgx over dx, right? So you get negative 1 u negative 2 u to the power negative 2 d over dx g of x, right? So I can substitute to u squared, u squared, that is u is g of x. So this is u to the power negative 2 is g to the power negative 2. So that means negative d over dx g of x, right, divided by g of x squared, right, which is equal to d over dx g to the power gx negative 1, right? So now I can substitute that in here. So I'm going to write it here because everybody can see it here. So I can write it here. This is equal to I'm going to write it here, gx to the power negative 1. This is f prime x, right? F prime x plus f of x, right? And substitute this one here, right? I'm going to erase that arrow. It's going to be multiply negative d over dx gx divided by gx squared, right? And then you have you can take this is you can write it as f prime x g x negative 1, okay, uh, plus uh, f of x divided by, so negative sign, you can take it negative sign g prime x. This is g prime x right here. This one is g prime x right here, g prime x, and uh, divided g of x squared, right? And this is actually g of x, just g of x, g of x. And that I can take a common denominator, g of x squared. This is f prime x gx minus f of x g prime x, and that's the quotient, this one. So I can write in total d over dx f over g is equal to f prime x gx minus fx g prime x divided by gx squared. So basically, if you know the chain rule and the product rule, you can do any derivate any function. You don't necessarily need to use the quotient rule, right? This is how you obtain that quotient rule by using the chain rule and the product rule. Now you should be able to use that uh, quotient rule and the product rule as well as the chain rule. There's other way that you can prove the chain rule, quotient rule as well, but you can do it in whichever you want. Let's take this example. Uh, we can use it without knowing the equation of the product quotient rule. So I'm going to use the chain rule and product rule in this case. You have f of x equals x over 1 plus x squared, right? Uh, and what I would do is I need to make it as a product rule. So what I would go is x times 1 plus x squared minus 1, right? That's my f of x. And then I apply the product rule, right? I can easily apply the product rule. Uh, I can find f prime x, right? X times d over dx 1 plus x squared minus 1, right? Plus 1 plus x squared minus 1 times d over dx x. Just apply the product rule. Now what I can do is I can use what I want to find is the d this part, right? Part 1. So I take that one, I will write it in here, d over dx 1 plus x squared minus 1, right? Um, let's take uh, y equals 1 plus x squared minus 1, right? 1 plus x squared minus 1, and u is equal 1 plus x squared, right? And then your y is equal u to the power negative 1, okay? U to the power negative 1. Then I can find du dy over dx is equal to d uh, y over du times du over dx. That's my chain rule, right? This is the chain rule. So if I use the chain rule here, right, what is y is u to the power negative 1. So it's have d over du, u to the power negative 1 times du over dx. It is d over dx 1 plus x squared, right? So you have negative 1 u negative 2, right? Negative 1 minus 1, negative 1 minus 1 plus, we can use the sum, sorry, times d over dx 1 constant rule, and then the again d over dx x squared, right? So we can use here d over dx xn equals n times xn minus 1. So that's the same thing that I have used here. So it's minus 1, this u to the power negative 2. Uh, the first term is 0, it's a constant, plus 2 times x. So you have negative 2x divided by u squared, okay, u squared. So u is equal to negative 2x, u is equal to 1 plus x squared, right? So now I can put that answer back in here because I found this one. This one is what? This one is equal to negative 2x divided by 1 plus x squared, right? And I'm going to put that in here, x times negative 2x divided by 1 plus x squared plus, this is 1, right? I can put this one 1 over 1 plus x squared, right, times this is 1, which is equal to uh, negative 2x squared divided by 1 plus x squared plus 1 over 1 plus x equals 1 plus x squared, uh, 1 plus x squared, right? If I multiply with this one, 1 plus x squared minus 2x squared. So we have 1 minus x squared, right? 1 minus x squared divided by 1 plus s squared squared. Right? That's the one way of solving that, using the product rule and chain rule, right? Using the product rule and chain rule. And if I want to use the quotient rule, I can do that as well. In that case, you need to remember that another equation. So you are given this using quotient rule directly. So you have d over dx, x over 1 plus x squared, which is f is, so uh, you can say that uh, d over dx f of x over g of x, where f of x is x, g of x is 1 plus x squared, right? So I can write uh, g of x times f prime x minus f of x g prime x divided by gx squared, right? So what is g of x is 1 plus x squared, right? f prime x, f prime x is, what is f prime x? 1, right? So you have 1 minus fx is x, g prime x, d over dx 1 plus x squared, right? Divided by gx squared is 1 plus x squared squared, right? So we have 1 plus x squared minus x times uh, the first term is 0, second term is 2x, right? We have 1 plus x squared squared. So we have 1 plus x squared minus 2x squared divided by 1 plus x squared squared, right? So we have 1 minus x squared divided by 1 plus x squared squared. Same answer. If you remember this equation very well, you can follow that, or you can remember the chain rule and product rule, and you can apply that and get the same answer. You divide, get the same answer in two cases. And again, we can use another equation, another question: d over dt uh, e to the power t divided by e to the power t plus 1, right? Uh, I can do this as using quotient rule. So if I use uh, this, I can use f of t, g of t is e t plus 1, d over dt, et, that's f of t, minus e of t, e to the power t, d over dt, et plus 1 divided by e to the power t plus 1 squared. That's your gt. So I can use e to the power t plus 1. This is just e to the power t minus e to the power t times d over dt using summation rule. E to the power t plus 1 is d over dt 1 divided by e to the power t plus 1 squared. So we have e to the power t plus 1, e to the power t minus e to the power t. The first derivative is e to the power t plus 0 divided by e to the power t plus 1 squared. From the first one, you get e to the power t times e to the power t, that means e to the power 2t plus e to the power t. minus e to the power 2t divided by e to the power t plus 1 squared. This cancels with that, and then you have e to the power t divided by e to the power t plus 1 squared. That's d over dt e to the power t e to the power t plus 1. And I can also use the product rule and chain rule and solve that. Uh, so if I directly use the product rule and chain rule, I'll show you quickly. Uh, this is d over dt e to the power t divided by e to the power t plus 1. So I can write as d over dt e to the power t. This is e to the power t plus 1 power negative 1. So my first function is e to the power t. So I can write e to the power t plus 1 to the power negative 1, right? And d over dt e to the power t plus e to the power t d over dt e to the power t plus 1 minus 1, right? So what we can do is we can take any function by using the uh, chain rule. So you have 1 over e to the power t plus 1. This is e to the power t plus e to the power t. This is like x to the power n, but or u to the power n, you can take e plus 1 as x, right? So you can write negative 1 e to the power t plus 1 negative 1 minus 1, right? So what I have done is this is considered as u, right? So and then uh, you can write d over dt, right? D over dt e to the power t plus 1. So derivative of that function, okay? And then you have e to the power t divided by e to the power t plus 1 minus, because this minus 1, e to the power t uh, divided by, this is e to the power t plus 1 squared, and this is what? Using the sum rule, d over dt e to the power t plus d over dt 1. And this is e to the power t divided by e to the power t plus 1 minus e to the power t divided by e to the power t plus 1 squared. This is e to the power t e to the power t plus 0. Okay? And then I can get the common denominator, e to the power t plus 1 squared. So we have e to the power t plus 1 e to the power t minus e to the power 2t. This is e to the power t e to the power 2t minus plus e to the power t minus e to the power 2t divided by e to the power t plus 1 squared. So this cancels with that. So you can end up with e to the power t divided by e to the power t plus 1 squared. So the same answer. And we can extend the chain rule a little bit or generalize the chain rule to any function by using uh, these. This is called general power rule and general exponential rule, which is what I have used in here. So from chain rule, you don't have to necessarily remember those, but it is useful to remember sometimes. D over dx, g of xn is equal to xn equal to n times uh, g of x uh, n minus 1 times g prime of x for any number. And also we can write d of d over dx. These are actually direct consequences of chain rule. E g of x is equal to e to the power g of x uh, g prime of x. Okay. Uh, so we can use those things later uh, in our problems. Uh, for now, we will try some problems with those in mind. So if I take a couple of problems with the product rule and quotient rule involving involving this chain rule as well. So if I take this function f of x equals, this is actually problem 3.3, problem 12, 3.23 problem, f of x equal e to the power x divided by x squared plus 1, x squared plus 1. Uh, so here we have uh, I can take it as a product rule here. So f of x equals e of x x squared plus 1 negative 1. So if I take this is like g to the power, so I can write if I take f of x e to the power x, right? This is g of x to the power negative 1, right? So here g of x is x squared plus 1, right? And then I want to find d f over dx. Now what I would do is I would put the product rule e to the power x, right? Uh, let's put it like that. You put g of x minus 1, right? E to the power minus 1. The first function is d over dx, e to the power x plus e to the power x d over dx uh, g x to the power negative 1. So we can keep this 1 over gx times e to the power x, right? Plus e to the power x. Now we're going to use this one, n g of, this is d over dx g to the power n, right? So n is negative 1, the same thing in here, negative 1 and negative 1 minus 1, right? So you can put uh, g of x negative 1 minus 1, right? Squared, right? So you can have e to the power x gx, and you have minus e to the power x g of x squared. So you have g of x squared to the power x dx minus e to the power x, right? So I'm going to multiply, substitute the x squared plus 1 instead of g of x. So I have e to the power x, x squared plus 1 minus ex divided by x squared plus 1 squared. So this can be written as ex x squared plus e to the power x minus e to the power x divided by x squared plus 1 squared. So you can cancel this out. You can put e to the power x squared divided by x squared plus 1 squared. So that's your df over dx. So we didn't use the quotient rule. Actually, we used the extension of the chain rule and the uh, product rule to get this done. And likewise, we can do any other uh, function, uh, any product rule, chain rule, uh, or the quotient rule functions. Uh, let's take another example finally. Um, let's take 26. Let's take 33 probably. No, that doesn't have a constant. 35. Let's say 35. 35. So it's f of x equals e to the power x divided by x plus 1, right? So in this case, we take uh, ex times x to the power 1, x to the plus 1 minus 1. So that's f of x. Let's take h of x is equal to x plus 1. Now I can write my f of x equal to e of x e to the power x times uh, hx minus 1. So what did we learn before? We learned that uh, from the previous page, uh, d over dx g to the gx to the power n is equal to n times uh, gx uh, n minus 1 times g prime x, right? E prime x. So this is n is negative 1, right? So I can write f prime x is equal to uh, hx negative 1 d over dx ex plus ex times d over dx hx negative 1. So I can write um, this is 1 over hx, this is e to the power x plus e to the power x, and now I'm going to apply this rule here, right? N is negative 1, h of x, right, to the power negative 1 minus 1 plus d over dx hx. right? And we have e to the power x over hx minus, because this minus sign minus 1, e to the power x divided by hx squared, and d over dx x plus 1. So I can take e to the power x h over or to over hx minus e to the power x over h of x squared, and then this is using the summation rule. This is 1 plus 0, right? So we have h of x divided by e to the power x, right? Minus, this is just 1, e to the power x, right? E to the power x, this is e to the power x, this is just 1. So you get uh, h squared, so I need to multiply this by, sorry, this mistakes, h of x minus e to the power x. So h of x, e to the power x, h of x is 1 plus x, or x plus 1. Let's put x plus 1 minus e to the power x divided by x plus 1 squared. So we have x times e to the power x plus e to the power x minus e to the power x divided by x plus 1 squared. So cancel these two. You get x e to the power x divided by x plus 1. So that's how you apply the chain rule and the product rule. And if you want to apply the quotient rule, you can do that as well. Uh, so if you want to directly apply for this case, the quotient rule, what you can do is you have f of x equals ex over x plus 1. So you need to find df over dx, which is actually x plus 1 d over dx e to the power x minus e to the power x d over dx x plus 1 divided by x plus 1 squared, right? And then you can do x times e to the power x plus, uh, because I just need to write the extra step, plus 1 e to the power x plus minus e to the power x. So this is just 1 plus 0, right? Divided by x plus 1 squared, right? So from there you can take x times ex, e to the power x, minus e to plus e to the power x, minus e to the power x divided by x plus 1 squared. We have x plus 1 squared, and so those two, x times e to the power x. Same answer. You'll be getting the same answer. Okay. All right. So now you might have understood how to apply the chain rule and product rule, and in combining the chain rule and product rule, you can apply the uh, quotient rule. So we did a couple of examples with chain rule, with product rule, and then the product rule and chain rule, and then the quotient rule. And sometimes you have a little bit of complex problems like the next one that I'm going to show you, uh, which is a case of chain rule. So in this case, we have a function just given by you have to find d over dx of uh, square root of 1 plus square root of x squared plus 1. Now to this one, I can use the chain rule. I defined u equals 1 plus x squared, square root of x squared plus 1. Uh, and then you have to use the chain rule once again because you have inside function in this one. So if I defined my v as, so this is v, let's say this is g of x, right? V as now let's take like this. So you define this as g of x. So your y is actually uh, square root of u. Okay, square root of u. So what I can do is I can take d over dx square root of 1 plus square root of x plus 1 is equal to, if I apply the chain rule, uh, I can use d over dy u d over du plus du over dx. Yeah? And I can do that. Uh, this is d over du u to the power half times d over dx 1 plus x squared plus 1, and this is negative half times u negative half minus 1, right? Times d over dx uh, 1 plus x squared plus 1. Okay, x squared plus 1. And I can use the same chain rule for the second one. So what I would do is I can use the this is u, so negative u to the power 3 halves divided by 2 times d over dx 1 plus d over dx square root of x plus 1, right? And if I define from here, I'll take uh, v is equal x squared plus 1, right? V is equal x squared plus 1. Then your h would be, right, square root of v, right? Square root of v. And then we can write the functions. Uh, Continue this one. D over dx square root of 1 plus, I should have written this one over this side. I'll take my v is equal uh, x squared plus 1, and then your h is equal to v, right? And then I can write to u that over 2. This is 0 plus. Now what I need is d, uh, so your y is equal to, yes, you need dh, right? dh over dv times dv over dx. Again, using the chain rule, right? So we have negative u that over 2. This is 0. Uh, Actually, this is plus dh over v. That's going to be d over dv. And dv over dx is that. And you have negative u 2. This is 0, and I don't want to write it again. So this is negative half v to the power negative 2/3 plus 2x plus 0. And you have this negative half and negative half is 1/4, and u to the power negative 2/3, and then we have v to the power negative 2/3 times 2x. That cancels with that. And you have 2. U is 1 plus x squared plus 1. So you have 1 plus square root of x squared plus 1 to the power negative 2/3 times v is x squared plus 1 to the power negative 2/3. Okay, times, oh, so this should be actually, so I made a mistake here. I made a mistake. This should be uh, negative half. So I'm going to correct that, negative half in here. So this is plus half and minus 1. So this is going to be negative half. So this is positive half. This is positive as well. Yes, positive. This is half. This is 1/2. This is positive. Because this is positive half, and then that's why it's positive half. And it's going to be negative half. And this is also positive half. And this is positive 2. And that's a negative half. And in that case, both of these gonna be negative half and negative half the power, and that's okay. 4 to 2, and then you have 2. This is gonna be 1/2, gonna be negative 1/2 and half. So you have, this is the solution. Uh, so this is the time that we use, an instant that we use chain rule twice. It's a little bit of complex problem using chain rule twice. So in summary, we learned the product rule, which is d over dx f g is equal to f times d over dx g plus g times d over dx f. And chain rule, we have uh, d u over, sorry, d dy over dx is equal to dy over du plus times du over dx, where uh, u is a function of x and y is a function of u, right? Uh, and in that case, y is a function of g, so y is a function of g of x, something like that. Say this is gx. And then product rule, sorry, quotient rule, d over dx f over g is equal to g squared g times d over dx f minus uh, f times d over dx g. And we also learned that, I'm going to write it here, we also learned that d over dx g to the power n is equal to n times g x n minus 1 g prime x. And then we also learned that d over dx e to the power g of x is equal to e to the power g of x times g prime of x, right? We learned those things, and by using those things we can solve many problems. Thank you very much for listening, and